Hello everybody, in this video I'll talk about relational algebra. Relational algebra is a procedure query language that is used to interact with the database tables. It is used to retrieve data from the database or manipulate database insert records. Actually, relational algebra is a procedural language. That means user has to specify sequence of operations on the database to compute the desired result. Relational algebra contains a set of operations that take one or more relations as input and produces a new relation as result. There are 6 fundamental operations in relational algebra. First one is select, then project, union, set difference, Cartesian product, rename. Among these 6 relational algebra operations, some of them are unary, some of them are binary. Unary means that operator will take only one relation as input. Select, okay, this is unary. Actually, it will be working on only one relation. Project is also unary, and this rename, this is also unary. But union, set difference, Cartesian products, these operators will work on 2 relationships. So these are binary operations. Now let's talk in detail about these relations. Select is a relational algebra operator which is used to retrieve records from the database table if specified conditions are met. Okay, to retrieve the record from the database table and on the basis of some condition. In that case, we will be using select operator. Select operator will take relation as input. Here I have created a customer table. It consists of customer ID, name, address, gender, email and height. So if I wanted to retrieve the record of customers whose address is Baneswar, then I have to write like this. Select operator is denoted by sigma letter, that is the Greek sigma, and we will be specifying this condition as a subscript. Here in this slide we can see address is equal to address is written as subscript. That is the condition, and this is the relation from where we wanted the records. So if we want to retrieve records on the basis of some predicate or condition, then we will be using select operator. Select operator retrieves all the attributes of the relation. Here another example is there. This operation will retrieve records of those customers who are female only. Similarly, we can have a compound predicate also. Here this select operator will retrieve those customers whose height is greater than 65 and whose height is less than or equal to 68, and this is the result. This is the resulting table of this query, where the customer's height is greater than 65 and less than or equal to 68. So in this way we can be using select operator to retrieve record of those people whose conditions are met. And you can see here it is working on only one relation. So select is unary operator. Now let's move to another operator, that is the project. Projector operator allows to retrieve specified attributes or columns from the given table. Projector operator is denoted by Greek letter pi. So here first example is given where name and gender of customers are retrieved. Just specified attributes if you want. In that case we will be using project operator. So result of this action, this operator, is cname and gender. Name and gender of customers are specified. I should have written here cname instead of name only. So let's correct this, because the attribute of customer is name and gender. So okay, cname, okay, I'll correct this like this, cname and gender. So if you want to retrieve only specified attributes, then we will be using project operator, and this is also unary operator as it works on only one relation. You can see the relationship is specified within the braces. So if you want to extract only name of the customers, then we have to write name as the attribute as a subscript to this pi, and we have to specify the relationship's name. So in this way we can work on relationship and extract specified attributes using project operator. Now, composition of relational operators. We can use select and project at the same time. Two or more relational algebra operators can be used to retrieve data. For example, to retrieve name of only those customers who are from Banishore. Name, here we are trying to retrieve the name of those customers who are from Banishore. So first we have to extract the record of those customers whose address is Banishore. So what we have to do? First we have to write this select operation. We have to retrieve the customers whose address is Banishore, and for that we have to use select operator with the predicate address is equal to Banishore. This operator will return this result. This is the table returned by this select. Okay, so it will be containing only one record, because in the previous table we have seen here there is only one person whose address is Banishore. Okay, so when we apply this select address equal to Banishore and relationship customer, we will get this result. We will this table, and from this table we have to extract the name of the customer. So what we do, we will be writing the project operator here. We will project the CNAME only from this table. So the resulting relation will be CNAME containing only one column CNAME, and this is Dinesh. So in this way we can combine relational algebra operators. Now, union operator. When we have to retrieve records from two different relations, then we will be using union operator. Okay, to use the union operator, some conditions must be satisfied. The conditions are: the two relations R and S must have same number of attributes. The relations of which union we are going to take, they must have same number of attributes. That means if R has 5 attributes, then S also must have 5 attributes. The domain of ith attribute of R and ith attribute of S must be same for all I. That means if the domain of first attribute of R is string, then the domain of first attribute of S must be string. If the domain of fifth attribute of R is integer, then the domain of fifth attribute of S must be integer. So that rule is known as union compatibility rule. Number of attributes in both relations must be same, and the domain of ith attribute of first relation and the domain of ith attribute of the second relation must be same for all I. Now let's see how we can use this union operator. Okay, here I have written a simple example. I am taking a union of name of employees and customers. Here we have two projects. First, this will retrieve name of employees, and this will retrieve name of customers. So the results of this projection will contain only one attribute. Similarly, result of this projection will also contain only one attribute. The first condition of union compatibility is satisfied, and the domain of name in employees is string, and similarly the domain of names for customer is also string. So the second condition is also satisfied. So we can take union of these two relations. Okay, and as we take the union of these two projections, we will get the answer like this: Savina, Shankar, that exists within employees, and Amit, Devika, Sujita and Ramesh within the customers. Here Ramesh is not repeated because set does not contain duplicate values. So duplicate values filter out. So in this way we can take union of two different relations. Conditioned union compatibility must be satisfied. Now set difference is the another operation. Set difference is denoted by a minus sign, and it allows to retrieve records that are in one relation R but not in another S. R minus S will produces a relation containing those records in R but not in S. And to perform the set difference, union compatibility rule must be satisfied, which we initially talked in case of the union operations, that set compatibility must be satisfied for set difference also. So we can do the set difference here something like this. we are projecting the name of employees and we are deducting the names of customer from employees. So whatever name available or visible within the employees, that will and that not available in the customers will be displayed. So here Savina and Shankar are the two names which are in employees but not in customers. So the result of set difference between names of employees and customers names is Savina and Shankar. Here Ramesh appears in both relation. Ramesh appears in employees and customers, so Ramesh is not displayed. So according to the set difference R minus S, it will produce the relation containing those records in R but not in S. So here name of the employees we can assume it as R and name of the customers as S. So in case of R we are having Ramesh, Savina, Shankar. In case of yes, we are having Amit, Devika, Sujita and Ramesh. And in this case, Savina and Shankar are the two names that exist within the R. So the result is Savina and Shankar. Cartesian product. Cartesian product is denoted by multiply sign that combines information from any two relations. Cartesian product of relations R1 and R2 is written as R1 multiply R2. Let's suppose number of records in R1 is N1 and R2 is N2 and number of attributes in R1 is A1 and R2 is A2. Then the resulting relation means R1 into R2. When we perform that, it will generate the new relation, and in that relation the number of record will be N1 into N2. N1 is the number of records in R1, N2 is the number of records in R2. So the number of records in the resulting relation is N1 multiply N2, and the number of attributes in R1 multiply R2 is N1 plus N2. That means the number of records of these two relations get multiplied and the number of attributes are added. So now let's see an example. Here in this case in R1 we are having EID, name, address, and R2 we are having name and gender. R1 has 3 attributes, R2 has 2 attributes. R1 has 3 records, R2 has 4 records. So according to the rule of the Cartesian product, here we don't have to consider union compatibility. We can take Cartesian product of any relation. So according to the rule of Cartesian product, the resulting table will have 3 multiplied by 4. That means 12 records, and now the number of attributes is 3 plus 2, that is 5. So the resulting table should have 12 records with 5 attributes. If the name of attributes are same, then they should be distinguished using the relation name. So here name exists in R1, name exists in R2. So in the resulting table we will be writing R1.name, R2.name. So let's see the result of R1 into R2. So this is the result of Cartesian product R1 and R2. We can see here there are 4 records. Ramesh Godagodi is multiplied with Amit, Ramesh Godagodi multiplied Devika, and then Ramesh Godagodi Sujita, and Ramesh Godagodi with Ramesh. This is a customer. Similarly, Savina has to be multiplied with Amit, Savina has to be multiplied with Devika, Savina has to be multiplied with Sujita, Savina has to be multiplied with Ramesh. In this way, we can get the records after doing the Cartesian product of two relations. So just remember, number of records get multiplied and numbers of attributes get added. From this resulting table, we can extract other informations, like we can perform select operation in this R1 and R2. Here I'm trying to retrieve those records for which name of R1 and name of R2 are same. So only the record that will be displayed will be of Ramesh, because Ramesh exists in both R1.name and R2.name. So in this way we can perform the Cartesian product. And remember, Cartesian product is the most expensive operation in the relational algebra or even in SQL, because it is a time consuming process. So in terms of time consumption and memory space consumption, it is very, very expensive. If there are 1000 record in R1 and 2000 record in R2, then the number of records in R1 and R2 will be 1000 multiplied by 2000. That means there is a huge number of records. So remember, Cartesian product is an expensive process. Now the last fundamental operator of relational algebra is rename. The results generated by relational algebra does not have any name. The results of relational algebra expression do not have names. To give name for results of relational algebra, the rename operator can be used. Rename operator is denoted by Greek letter rho. So rho, and in the suffix we will be specifying the name of the relation. So here R1 and R2 is done Cartesian product, and selection is performed at that or R1 and R2. So in order to give name for this resulting result, we can be using this rho operator, and the name of the new table will be similar. We can see here rho is used and the name of the relation is similar, and this is the relation for which the name will be similar. So in this way we can use the relational algebra to query the database. Thank you very much for listening, and if you like my videos, kindly subscribe it. Thank you very much.